Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss electrodialysis. Electrodialysis. First I will tell about working principle of electrodialysis. Electrodialysis process is based on the principle that the ions migrates towards oppositely charged electrodes when an EMF is applied. The direction of ions movement is further made specific by using ion selective permeable membrane. The cation membranes are permeable to only cation, while anion membranes are permissible to only anion. The process thus yields pure water by decreasing salt concentration. This is the principle of electrodialysis. The process of decreasing the concentration of salts in saline water using ion selective membranes under the influence of an applied EMF is called as electrodialysis. Again, I am telling you, the process of decreasing the concentration of salts in saline water using ion selective membrane under the influence of an applied EMF is called as electrodialysis. Here, three important parts are there. In electrodialysis, three important parts are there. First, that is the electrodes. You will use the electrodes. Then here two types of electrodes are there, cathode and anode. Cathode is negatively charged and anode is positively charged. This is the first requirement. It is the anodes and cathodes. Second requirement, that is membrane, ion selective membrane. Means one will be, it is of two types, cation membrane, cation membrane, and second is anion membrane. Okay, it is specific. This is a specific cation ion selective membrane, and second anion ion selective membrane. Means cation ion selective membrane only it will allow to pass cation, and anion ion selective membrane that will allow only anion to pass through it. Cation, you know, that is the positively charged ion is called cation, and a negatively charged ion is called anion. Correct? Then salt is made up from these two ions, cation and anion. As for example, sodium chloride, salt. In kitchen we are using that salt. This is a common salt, also called table salt. When it is dissolved in water, then it will ionized. After dissolving in water, it will produce cation and anion, means positive charge and negative charge ion. It will produce, means Na plus Cl minus, two type of ion it will produce. Then any salty water, sea water, ocean water, any salty water contains so many salts, not only NaCl. In chemistry, many salts are there. Sodium chloride, potassium chloride, calcium sulfate, magnesium sulfate, many different type of salt, phosphate, all are present. Then here, just for simplicity, for understanding purpose, you consider only one salt. Suppose in water, NaCl is there, Na plus Cl minus is there, and you have to filter it. You have to filter it. Water you have to purify. Then how will you do? Then there actually I was telling about the parts. Then first part I told you electrodes. Second I told you membrane, ion selective membrane. And third part is actually DC voltage you have to apply. Direct current voltage you have to apply. Okay. That is a source of DC supply, just like a battery you can tell, and high capacity. From that you can apply the voltage, or you can tell current. Means after these things, connecting it to the anode and cathode, from the DC you will make connection. You will connect anode and cathode, correct? Then now these three parts are main in the electrodialysis, main requirement. Then now how will it clean? How will purify the water? That I was telling you that here three chamber will be there. In first chamber, salty water you will take, salty water, and in that chamber actually one side that anion ion membrane will be fitted. Anion ion selective membrane will be fitted. Other side cation ion selective membrane will be fitted. One side one membrane, cation membrane, other side anion membrane. Okay, any side you can fit anyone, not a problem. One side anion membrane, other side cation membrane, you can fit it. Then now this work is done. Two membrane you have fitted. Anion ion selective membrane, cation ion selective membrane. Okay. Now near this chamber, anode will be fitted. Anode will be fitted. A means anode, A means anion. Near the anion, anode, and near the cation, cathode. Cathode will be fitted. Correct? And there near the anode and near the cathode, one chamber will be there. Okay. Then total three chamber. One is the middle. In the middle, you have taken the salty water, and one side, anode side one chamber, cathode side one chamber. Then what will happen if you will apply the voltage? Means you have made connection. Cathode and anode you have connected with battery, DC, direct current, you can say source you have connected. Then what will happen? Now anode will become positively charged. Cathode will become negatively charged. Here I want to clarify. This is actually from the outside. You are supplying the current. This is actually called electrolytic cell here. But one more cell is there. That is called galvanic cell. Cell is of two type. Galvanic cell, also called voltaic cell, also called Daniel type of cell. Same name. Okay. Then galvanic or voltaic or Daniel cell, their situation is different. Anode will be negative and cathode will be positive in galvanic cell. But here case is reverse, because another type of cell you are using, that is a electrolytic cell. Then here anode will be positive, reverse of the galvanic cell. That anode will be positive, cathode will be negative. Means here A means anode and anion will be near, and C means cathode and cation will be near the cation membrane. Cathode will be there, near the anion membrane anode will be there. Anode is positive, cathode is negative. Suppose you have supplied the current, just you have done on, you have just now it is supplying, you have done the on. Now DC is on, then it will supply the voltage or current. Then what will happen, that here that anion and cation, anion is, I already told you, anion is negative charge, cation is positive charge. It will try to move towards opposite electrode means anion will go to the anode, cation will go to the cathode. There, and that chamber, near that chamber it will collect there, and in the middle chamber where you have taken the salty water, now it will be free from salt. Water is purified. Then this water you can use, this water through a pipe you can bring it out, and that can be used as a fresh water or pure water. And these anion and cation, now it is collected in the neighboring chamber. Then here this is called one unit. In one unit 3 chambers are there. Middle chamber in the middle where salty water was there, other side, left side one chamber, right side one chamber where ions collected. Then this is called one unit. Like that many unit will be there. 3, 4, 5, 6, 7 as per your requirement. How much water want to clean accordingly. Then all have same type of arrangement. Each unit will have anode, cathode, each unit. And in each unit you have to supply the volt. Correct? Then because many units are there, then where anion was collected, that side in that chamber also, because it is a continuous, many this are there, units are there, means like first unit 3 chambers are there. Then arrangement will be like that automatically, that where anion was collecting, their cation will also collect, okay, from the neighboring unit. Then like that way both side you can say neighboring, that where cation was collected, their anion will also collect, because other units are there, they will arrange like that. Then this cation and anion collected, that is also called it is a brine solution in the form of, so it will be solution, brine solution, concentrated salt solution, that you have to remove it through the exit, okay, that water can be removed. Then like that way water is purified. Then a suitable EMF depending on the level, of salt in brine is applied across the 2 electrodes immersed in brine, means where your salty water you are taken, near that only actually electrodes are fitted near the this middle chamber only, once both side. Then here this under the influence of the applied EMF, if you will apply the EMF, then sodium ion, particularly I am talking only for the sodium chloride, okay, that sodium ion, positively charged sodium ion, it will go to the negative negative anode. It will go this anion is negatively charged. It will go to the positive charge anode, and cation is positive charge, that will go to the negatively charged cathode, C to C, A to A. Cation is positively charged, it will go to the cathode, which is negatively charged. Anion is negatively charged, it will go to the positive anode. Okay, A will go to A, C will go to C. Then like that way you can say Na will means a positive charge, it will go to the negative cathode, and Cl is negative, that will go to the positive electrode, that is the anode. Okay, then like that way it will filter. The net result is the depletion of salt content in the, you can say, middle chamber, where salty water you have taken. From that there will be depletion, means salt will be less and less, very less. Okay, very less, and increase in salt concentration in neighboring compartment. In neighboring compartment, there you can say salt concentration will increase. Okay, the fresh water is produced in a ion depleted compartment. Fresh water is produced in ion depleted compartments and is collected and is pumped off. The concentrated brine produced in ion concentrated compartments, means neighboring compartment, there you can say brine solution will be collected, because many units are there. Then that concentrated brine produced in an ion concentrated compartment is discharged through the outlet. Then like that way pure water will be in the middle chamber, and other chamber, that is the salty, that is the, you can say, concentrated brine solution will be collected, because many units are there from every neighboring side. There will other ion will also come. One side it is coming anion collected, then from the other unit cation will come in the same chamber. It will form salty you can say, or concentrated salty solution it will form. Because in that also little water will be there in that chamber. Then that both fresh water also you can collect, and this water you can throw it. This salty or concentrated water can be discharged through the outlet. Then in this way you can say salty water can be purified by use of electrodialysis. And actually same type of this instrument is used in hospital also. When you can say patient their kidney is not working, kidney failed, then that time actually kidney also is just like a filter. It filters the water, body water. But if it is not working, then what to do? Person will die if it will not work. Then in there that dialysis is used. Same type of principle will be there to filter the salts. Then here what I discussed, that is for filtering the, you can say, this salty water. Salty water you can make fresh water or pure water by use of electrodialysis. Okay. Then now I am stopping only here. Thank you.